For this question, if you want to express the given expression in the completed the square form, okay, so x squared minus 8x plus 3, if I want to complete the square, I will get an x minus 4 square. Okay, so from this, I will actually get x squared minus 8x plus 4 squared. So this additional 4 squared has to be deducted such that the two expressions are still equal. Okay, so my plus 3 is there because of the original plus 3. Then I simplify and I will get this as my answer. This is for part A. Okay, for part B, the question wants us to hence sketch the curve y equals to x squared minus 8x plus 3. And the question specifies that they want us to show the turning point, the x and y intercepts clearly. Okay, since the question has asked for all this, the examiners will obviously be looking out for this. So we will definitely need to make sure that we have included these 3 items in our sketch. Okay, so now the thing is this: how can we actually make use of our answer in part A to help us sketch this curve? Okay, because they said hence. So from the completed the square form, it's actually possible, okay, for us to get the line of symmetry and the coordinates of the turning point of this quadratic function very quickly and very easily. Okay, so let's do a quick recall. If I have x minus a squared plus b. Okay, so the function y equals to x minus a, the whole thing squared, plus b. My line of symmetry will simply be x minus a equals to 0. So line of symmetry will be x minus 8. X equals to 8. Okay, so this is my line of symmetry. And working on this, the turning point lies on this line of symmetry when x equals to a. So my turning point will have coordinates a and b. When x equals to a, the y value is actually b. Okay, so for this question that we have here, we can easily get our line of symmetry and turning point. So let's go on to part B. Okay, so I have this function and I wrote down the completed the square form. Now 4 things that we usually look out for when I want to draw a sketch of a quadratic function. So I have S, the shape of the quadratic function. Now in this case, we have to look at the coefficient of x squared. The coefficient of x squared is positive, so the shape of the quadratic function that we have here be like this. Next, I want to find I, the intercepts. Okay, so there are 2 parts. I need to find the x-intercept, which you will get easily when x equals to 0. And you will get 2 x-intercepts when y equals to 0. So we just have to solve to find the x and the y coordinates. The next thing we need to find is the line of symmetry, okay, which we have already seen that we can get it very easily from the completed square form, and T, the turning point, which we also can get from the completed the square form. So I shall now continue to find the x-intercept and y-intercept. So when x equals to 0, y is 3. This gives me the y-intercept. Okay, so the coordinates of the y-intercept. Then, when I have y equals to 0, you can solve for the equation. You can solve by using your quadratic formula. Alternatively, you can also use the completed the square form from part A to help you. So x is 4 plus minus square root 13, which gives me 0.394, or 7.61 corrected to 3SF. The line of symmetry, since my equation is this, my line of symmetry will simply be x equals to 4. And my turning point will have coordinate 4, negative 13. Okay, so I need to now have a good idea of where my graph is centered. So I know that the line of symmetry is 4. Okay, so line of symmetry, x equals to 4. My turning point is at the bottom. Okay, and my x coordinates, my x-intercepts are both positive. My y-intercept, okay, so my quadratic curve will look something like this. This will be 7.61. This is 0.394. This will be 3. My turning point is 4, negative 13. Okay, so I just do a quick check if I have the following information given. Okay, so that's it for question 2B.